And this is one of my favorite sections in your book. So this is a lot of really fun and neat things. Of course, you've already been graphing lemniscates and lemnisons. You just didn't know it, but we're going to actually put names on them, and you're going to be graphing lots and lots of them. You're going to classify polar equations into their different classifications. There's circles, there's lines, there's cardioids, lemnisons, lemniscates, spirals, and roses. Some of those you've already been doing. You know what they are. You actually know what their names are. Some of them you've been doing, but you didn't know what their names are. So we're going to put names to them. And look. So classic curves generated by polar equations. These are what we typically see. Number one is a circle. Number two is a lemniscate. So this is a figure 8. So anytime that you have graphed a polar equation and gotten a figure 8, that's called a lemniscate. A lemnison is another type, and there's actually a special type of lemnison. It actually classifies even further. There's just a lemnison without a loop, a lemnison with a loop, and then there is a lemnison that is specifically a cardioid. Then we have a spiral, in particular Archimedes spiral, and then we have a rose, which you'll have been graphing knowing the number of petals. So first, let's talk about circles. R equals 2, right? We know that's a circle. R equals 2 cosine theta, that's also a circle. Notice the 2 in front of cosine, and notice that we are 2 out here. That is not a coincidence. That will help you know how to graph circles. So negative 2 cosine theta is on the other side. Notice that it's still at distance of 2 from the origin. 2 sine theta, okay, is up. And again, it's still 2 from the origin, so that's helpful to know. Negative 2 sine theta is down. Some polar equations can be translated into familiar rectangular ones, like circles. Like we know how to graph circles in the rectangular coordinate system. That's something that we learned about. However, others are not worth changing. For example, let's say r squared equals 4 cosine 2 theta, and we wanted to convert that back into the rectangular system. So the first thing we would have to do is we would have to convert to x's and y's. So here's the work for that. And I'm already but here's the equation. Here's the equation right here. X to the 4th plus 2x squared y squared plus y to the 4th minus 4x squared plus 4y squared equals 0. That's what r squared equals 4 cosine 2 theta is. So as you can see, if you wanted to graph this in the rectangular coordinate system, you would just get really frustrated in the beginning. So some are just better left in the polar coordinate system. So that particular type of polar equation that is better left in the polar coordinate system, it's called a lemniscate. Okay, so it has the form of r squared equals a squared cosine 2 times theta, right? So your big clue to classify it as a lemniscate is this r squared. Okay, also cosine 2 theta. That's another huge clue. Okay, so let's look at r squared equals 9 cosine 2 theta. Okay, it's going to be a figure 8. And notice that the distance from the origin is 1, 2, 3. And our a value is also 3 because 3 squared is 9. So that's something that can help you when you are trying to graph your lemniscate. So the a value will help you tell how far away from the origin you should be. What about 25 cosine 2 theta? So your a is now 5. So yes, now you will be 5 away from the origin. We can also have a squared sine 2 theta. r squared equals a squared sine 2 theta. And when that happens, what's going to happen is it's going to still be a figure 8, but it's going to be tilted. So it's going to be on a diagonal. And notice that it's still, that a value still tells you how far away from the origin you are. So it's also really good to know how to do this without your graphing calculator, just using the information. So let's talk about limicons, commonly mispronounced as limicons. I've heard people say them both ways, but it's very important to know that the limicons can be categorized into 3 different things. The first categorization is called a cardioid, and a cardioid is when the absolute value of A is equal to the absolute value of B. So what that usually looks like is R equals A times 1 plus cosine theta, which basically says that you should be able to factor out something from this constant term and the number of cosine. Those should be the same number. So for example, R equals 2 times 1 plus cosine theta, you might have originally had R equals 2 plus 2 cosine theta. So your A and your B are the same number. It's absolute value B, so one of them could be negative as long as that they're the same number. So let's see what that looks like. So a cardioid is, what it sounds like. It comes from the word for heart, right? So cardioid, it looks a little bit like a heart. If you see here, it's not quite a circle because it's going to come back into the origin. But notice this for me. Notice that from the origin, we've got 1, 2, right? Like that tells you that part of your heart, like whenever it reaches 2, that's when it needs to start coming back into the origin. So that's how you're going to know how to graph a cardioid. Without the aid of your calculator, is you can use that information. Okay, so let's do another cardioid. Let's do 2 times 1 minus cosine theta. So this might look like 2 minus 2 cosine theta because they're both 2's and you can factor out the 2. They did you the favor in this PowerPoint to go ahead and factor out the 2. I'm just letting you know that you're going to see it both ways. So 2 times 1 minus cosine theta is going to be on the other side because it's minus instead of plus. And notice that it's still 2, has that distance of 2 when we're looking at the heart part of your graph. So again, that's helpful in knowing how to graph it. All right. So what about if you use sine instead of cosine? Well, sine is going to be up and down. So 2 times 1 minus sine theta, the minus means it's going to go below. And again, the 2 tells you this distance here. Okay, so that way you're going to be able to graph this without a graphing calculator. Okay, so what about next classification is limicons without a loop. So without a loop. And then what happens is that your A value, which is your constant term, is going to be bigger than your B value, which is the coefficient in front of cosine or sine. So if your constant term is bigger than your coefficient term, then you're going to have a limicon without a loop, which means that the third classification is with loop. So for this one, it's without loop. So 3 plus 2 cosine theta looks like this. So notice it's still more of a cardioid, but this limicon is not on the origin. And I think that's the huge takeaway there, is that your limicon is not going to be on the origin. It's going to be out. It's going to be out, right? So you're going to pull it out, and that's where your heart's going to come to. But notice that your 3, and it's 1, 2, 3 from the origin here. 1, 2, 3 from the origin here. So that's still helpful to know, like that space should be 3 and 3 because your constant term was 3. And since it was A is greater than B, then it's going to be going out from the origin. It's still going to make a heart shape, just not as defined because it's not going all the way in to the origin. Let's look at 3 plus 2 sine theta. So remember, sine theta is up and down, and it's positive, so it's going to be up, right? Okay, and so again, the 3 gives us that distance there. The fact that 3 is bigger than 2 tells us that it's not going to be going into the origin. It's just going to go right there of a radius of 1, and then start going again. All right, so limison with a loop. This is when your constant term is smaller than your coefficient. So your A is less than your B, so 2 plus 3 cosine. So cosine again is left and right, so you're going to have a little loop right there. So this one's fun to do. It's almost like a cardioid, except for when you get to the origin, you're going to make a loop that goes one out, and then it comes back in. So notice that the constant term of 2, and that still helps us. It's going to be 1, 2 away, 1, 2 away. So very similar to a cardioid, the only difference is that you get to make a little loop inside. Okay, and so so sine theta, which means up and down, it's positive, so it's going to be going up. And there's your little loop. And the constant term is still 2, so you still get 2 from the origin out. 1, 2, 1, 2. Okay, so 2 minus 3 sine theta. So now that it's sine, it's still up and down, but since it's minus, we're going to go below, right? So it's going to be going this way. The constant term is still 2. All right. So next thing, we have our spiral, which is anything that is r equals a times theta. So r equals theta is this, okay? This is also called Archimedes spiral from the person who discovered it. So just so you know, spiral, Archimedes spiral, a equals 2 theta. So notice how your spiral got wider. So that's how you're going distinguish that. So petals, we already talked about petals. So if it's odd, then you're going to have that many of petals. Okay, so for example, let's look at sine. Okay, 4 sine 5 theta. So you're going to have 5 petals. Notice the a value though. That a value is going to tell you the distance from the origin. So when you draw your petals, they will be 1, 2, 3, 4 from the origin because your a value tells you that. So that's a neat way to be able to graph these petals without using a calculator, is knowing that information. All right, so sketch the graph r equals 2 times 1 minus cosine theta in the polar system. So first thing we have to know, what is this? Well, this is a cardioid because your a value is equal to your b value. So it is cosine, which means it's left and right. It's negative, which means it's going to the left. And it has a value of 2, which means it's going to be 2 from the origin. So it's going to look like that. Okay, so sketch the graph r equals 3 sine 2 theta using polar coordinates. So when we do this one, there you go. So these were petals. It was 2, which is even, which gives us 4, and the a value was 3, which means it's 3 away from the origin. R squared equals 9 sine 2 theta. So R squared means it's a lemniscate, which means that it's a figure 8. It's sine, which means that it's going to be tilted, right? And your a value is 3, which means it's going to be 3 out. All right, so sketch the graph for the system. So we want to put these on the same graph. That's what a system means. And then we're going to test the points of intersections. So r equals negative 2 sine theta. That's a circle, right? R equals 2 times 1 minus sine theta. That's going to be a cardioid. There we go. Very nice. All right, so this is your time to practice. I'm going to pause for a second, but you pause the video and do your answer first, kind of quiz yourself, and then unpause the video and see if you got it right, okay? So name this curve, r equals 2 plus 3 cosine theta. All right, so you should have gotten number 3, a limison. And so since 2 is less than 3, it's going to be with a loop, correct? With a loop. R equals 6. It's a circle, right? Circle. R equals 2 times 1 plus sine theta. It's a limison. In fact, it's a particular limison called a cardioid because your A value is equal to your B value. R squared equals 16 sine 2 theta. It's a lemniscate, which is a figure 8. So it'll be, so it's sine, so it's going to be tilted, right? And it's 16s, which means that your ABL is 4, so it's 4 away from your origin. So R equals 4 sine theta. It's a circle, right? Because it doesn't have any petals. So it's going to be a circle. 2 cosine 2 theta. It's going to be a rose because it's going to have petals. And those roses will be 2 away. And there will be 2 petals. R equals negative cosine theta. The circle, there's no petals on it. R equals 3 times 1 minus cosine theta. It's a limison, a cardioid, right? Because your A value is the same. It's cosine, which means it's going to be left and right. It's negative cosine, which means it's going to be going to the left. Your constant is a 3, which means that you have that space of 3 from the origin. R squared equals 5 cosine 2 theta. It's going to be your figure 8, your lemniscate. So your distance from the origin is the square root of 5. R equals negative 2. The circle. R equals 2 sine 3 theta. It's a rose. So since it's odd, it means it's going to have 3 petals. Oh, did anyone catch my mistake on the previous rose where I said there was going to be 2 petals? Really, it would have been 4 petals, right? I don't know if anyone caught that mistake, but hopefully you go back and change your notes on that. All right, your turn. You're going to do 6.8, 2 through 6 evens.